Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will solve past paper question on gravitational field from Oxford University Physics Admission Test 2020. For this question, it is given to us that value of G at the Earth's surface, means at the surface of our planet is given, that is 10 newtons per kg, and at a distance capital R greater than Re from its center, the value of G is given, that is 2 newtons per kg. Question is asking us, we need to find out what is the radius of Earth Re in terms of R. First of all, let's try to sketch this problem so you can see a clear picture of this question. I'm using this image of planet, means the real image of the planet, to give you some real feelings about this question. Let's assume that this is the center of our planet and the distance from the center to the surface, this distance is equal to Re, and value of G at the surface is given, this value is Ge, and its value is equal to 10 newtons per kg. In this case, we are assuming our planet is a sphere. It's a perfect sphere. So the value of G at any point, value of G at this point, value of G at this point, and any point on the surface, value of G is the same. It is also given to us that at distance capital R, but capital R is greater than Re, and at that certain distance value of G is given, and that value is equal to 2 newtons per kg. We can also write down here, but R is the distance from the center of our planet. Let's say this is the center, and the distance capital R from the center, let's say this is the distance capital R, and at this point value of G is given, that is 2 newtons per kg. Question is simply asking us, we need to find out what is value of radius. What is the radius of our planet Re, we need to find out. Now the best way to start this question is that we can start with G, and G is small g, this is equal to capital G times m, and this is the mass of our planet divided by the distance from the center square. Now if you look at these two quantities, now the value of capital G and mass of our planet, these two are constant, so simply we can write down gr square, this is equal to some constant, we can write down here, and this is constant for the distance from the center to the surface, and this is also constant for the distance from the center to any other point in the gravitational field. Based on this concept, simply we can write down Ge times Re square has to be equal to Gr times R square. Now question is asking us, we need to find what is value of Re. So simply we can rearrange, we can write down here. So this is simply what we need to do. Now we just need to plug in values, given values of G, and we can find out value of Re in terms of R. Gr is given, that is 2, and G is given, that is 10. And R we can just take out of the square root, we can simply write this is R. So what we left with, we simply left with R divided by root of 5, and this is our final answer. So option D is correct. So this is the answer for this question.